For this one, if we look, we have our right angle here, and across from there is the 15. That means 15 is our hypotenuse. So when I set up the Pythagorean theorem for this, A and B are the legs, C is the hypotenuse. So for this one, I'm going to say I don't know what A is. I do know that one of the legs is 8, and I do know that the hypotenuse is 15. So let's do these squared pieces, use the exponents. I still don't know what A is, but this is 8 squared is 64. This, 15 squared, is 225. So here's our problem. This looks different. The 225 and the 64 are not together over here for me to add them up. This is really the same thing as what we've done with solving a one-step equation. Raise your hand if you think you know what I can do to try and find out what A is. David? Absolutely. This is an equation, right? We have an equal sign. So if I want to get A by itself, I better start doing the opposite of what I see. Instead of plus 4, I will subtract 4. I'm sorry, 64. So I now have that A squared equals, and now I need 225 minus 64. 5 minus 4 is 1. 22 minus 6 is going to give me 16. So I have 161. We saw this in the last example. I don't want A squared. I want A. So what did we say is the opposite of squared? Square root. So I will square root both sides of this equation. Square root cancels squared, and I have what I want, A by itself. But now I have the square root of 161. When I have the square root of 161, the problem I am faced with is I don't know if I can simplify this. So I have to ask myself, does 4 go into this? 4 is a square number. No. Does 9 go into this? Well, do you know that for sure?
Yes.
You got to double check that. 9 won't go in. Does 25 go into it? 16 go into it? 49 go into it? Do any of these go into it? And you have to run through this whole process to try and figure out if any of them work. For us, in this one, none of our square numbers fit into 161, so we will leave it exactly how it is. If it cannot be simplified, we leave it as the square root of 161.